Welcome back to our YouTube channel. Today we are going to see Codeforces problem B, that is Equalize. Okay. So in this problem, Vasya has two hobbies: adding permutations to arrays and finding the most frequently occurring element. Recently, he found an array A and decided to find out the maximum number of elements equal to the same number in the array that he can obtain after adding some permutation to the array. Okay. So more formally, what we can say, first I must choose exactly one permutation from P1 to Pn of length n, then change the elements of the array A according to the rule Ai equal to Ai plus Pi. After that, Vasya counts how many times each number occurs in an array and takes the maximum of these values. Okay. So we need to determine the maximum value he can obtain, right? A permutation of length n is such that it contains 1 to n number and it can be any order, but numbers should not be repeated. That is the main. That is our main goal. So what we need to do, we need to find out the maximum number of elements equal to the same number after operation of adding a permutation, right? So let's see a simple case. First case, that is 1 and 2. So we can have permutation of 2, right? So that will be 1, 2 and 2, 1. That is the only thing possible. So suppose if you add 1 and 2, so that becomes 2 and 4. So is there any number which is repeated? No, right? So that is we need not to do that. We need to do some other way. So we'll take one more example, not one more example, the other case 2 and 1. Now if we add these, that will be 3 and 3, right? So we can have one number two times. So answer will be 2 here. Perfect, right? So we can have the answer 2 here. Let's say if you have not understood the problem, then this example might help you. 7, 1, 4, 1. So we can take permutation like 1, 2, 3, 4, or 2, 1, 3, 4, so on. Right. So what we can do? We can add here anything like 1, 2, 3, 4. So it becomes 8. This is 3. This is 7. This is 5. So any elements that is repeated? No. So this permutation is bad permutation for us. So we'll not take it. Let's see, we can have 2, 3, 1, 4. Okay, we have taken this. So this gives 9, 4, 5, and 5. So this can give us two same numbers. So 2 is our one of the candidate. Okay, let's see some more thing. That it we can have hmm, instead of this we can have 2 here, or no, we can have 3 here. Let it be no 3, 4. We need to have 4 and then 1. We can we need to make combination as such that we can have the same number. So this is the best possible example for us. What we can have 2, 4, 1, 3. So this can give us 5. That's it. 5 and 5. This is 9 and this is 4. So two numbers are possible. That is the maximum possible. So here is the you need to understand, because we have a permutation from 1 to n and we can't repeat any number, right? If we can't repeat any number, that means if we are adding 1 here, then we can't add the same number here. That means having same numbers already is not making any sense, right? So we need to remove this. So let's see example. We'll consider the same case like 7, 1, 4, 1. So if we remove these, then it will be 7, 1, and 4. So like just think one more solution, one more like way. Because like we are not like interested in the order. We are interested in the elements. So we can sort. Why? Because so that we can make the like we can go in the sequence. I'll help you. So let's say 1, 4, 7. We have sorted this. Right. So let's suppose now you have a permutation of 1, 2, 3, 4. Let it be you have taken this 4 and put it here. This becomes 5. So yeah, your target candidate is 5. We need to make it 5, right? So what number we can choose here? We can choose here 1, right? So that becomes 5. Now, can we make it 5 by adding any number with 7? No, obviously not. So it is not possible. So we can have only two numbers possible, right? That's why we have done sorting, because we can go ahead easily and check that how many numbers are possible. So like again is the case, like we need to go each iteration, each item, check if it is possible or not, if it is possible or not, like that. So what we can do? We can think of a number. Let's erase only this thing, this part. We can think of a number like here we have 4. We have added 4. Okay. The first case we have it related from I equal to 0 to n, obviously. Okay. So we have added this. So we have a 5 hour target. So we need to find the lower bound of 5. Right. Lower bound of 5. Lower bound of 5 is what? This number. Obviously. So that is the index 2 from starting. So 2, 2 minus 0. So you can have two answers is the possible. And in one of the variable, you can have the answer variable at 0, and you can take the max of current and the previous. Right. So let's suppose instead of adding here, we have added here 4 and 4. That is 8. How many elements are possible to make 8? We can have this also 4 and 1. That can help you. Two elements. Like this is 8 and this is also 8. So we can make two elements again, but 2 is the maximum, so we'll keep it. And let's say like I'll help you to understand one more case. You might be thinking, let's suppose you have 1, 2, and then 10, 11, 12, something like that. Big number. So like if you add here the same number and adding here, so your initial elements will be discarded, obviously. And why we are adding here? Because it is possible that lower bound can be increased because it can be concentrated. Here it is not concentrated. Let it be it is 9. So it is not concentrated, but here it can be concentrated. So it can give the 3. But from here it is only possible 2. Right? That's why we are doing that. So let's see the code, the implementation. So okay, we have taken the unordered map because we want to eliminate the duplicate. So I'm doing while taking the input. I'm doing that. Right. Then what we have done? We have just sort the vector. Then iterating from each point, taking the lower bound, minus from starting, and decreasing the minus, like removing the ith element. Not ith element, first I elements. Why? Because these are not possible. We can't consider them. Then take the maximum and print that. That's it.